Okay, today we're going to talk about two new functional groups. We're going to talk about alcohols and we're going to talk about ethers. An alcohol is a functional group that is a hydroxyl group, an OH from the hydroxide ion. So it's a hydroxyl group that's bonded to the hydrocarbon chain of some sort of alkane. So no double or triple bonds here, just single bonds, but we have somewhere a hydroxyl group. A phenol, it contains a hydroxyl group bonded to a benzene ring. So we talked about aromatics the other day, and so a hydroxyl group on an aromatic compound is known as a phenol. Ethers have two carbon atoms attached to a single oxygen atom in the middle. So there are two carbon atoms on either side of the oxygen. The geometry around each oxygen atom is bent. Remember, the oxygen atom has two lone pairs of electrons, giving us that bent shape around the two bonds around the oxygen. So here we have some very simple alcohols, phenols, and ethers. So here we have the simplest one. Here is a methyl group with an OH on the side, so it's known as methanol. So you can see the carbon, and here's the bent oxygen atom. Here we have the phenol. Here's the benzene ring with its single and double bonds alternating. And then here's the oxygen on the side and the hydrogen. Then we have here an ether. Here we have a methyl group on either side with an oxygen in the middle. You can see the red oxygen, and then a bent with two methyl groups. This is known as dimethyl ether. Alcohols are named with the IUPAC system that takes the E in the alkane name and replaces it with OL. So some simple alkanes can sometimes be named with the name of the alkyl group followed by alcohol. So for this one, this alcohol here we see methane, and with CH3 changing to methanol, and then that's the IUPAC name. And a more common name for these the simpler alcohols, here's a methyl group and here's the alcohol group, so it's known as methyl alcohol. If we just have one or two carbons, we do not need to number the hydroxyl group. So here we have an ethyl group, CH3 and CH2 with an OH, so that's ethanol or ethyl alcohol. But if once we get to three or more carbons, the chain is numbered and the OH group gets the lowest number. So here we have 1, 2, 3, 4 carbons. 4 carbons is butane. So the OH makes it excuse me, makes it butanol, and it's on carbon number 1, so it's 1-butanol, or known as butyl alcohol. So here we have an example of naming the IUPAC name for this alcohol. So the first thing we need to do is we need to name the longest chain attached to the OH group. So here we see I have 1, 2, 3, 4, 5 carbons attached to the OH group. So 5 carbons is pentane, so we change the E ending to OL, so it's pentanol is our parent chain. We number the chain so that the OH group gets the smallest number, so I'm numbering this backwards, 1, 2, 3, 4, 5, so that the 2 carbon has the OH group, so then it's known as 2-pentanol. And then we have 1 substituent group on carbon number 4, so it's 4-methyl 2-pentanol. So here's a couple more to practice. So looking here, I see I have 1, 2, 3, 4 carbons. So that is butane. So it's butanol. And then I'm going to number my carbons. 1, 2, 3, 4. So that the OH group gets the smallest number, so it's known as 2-butanol. So there's no other substituent groups, so that's the name. Looking at B here, my longest chain is 1, 2, 3, 4, 5. So 5 carbons is pentane. So change that to OL. So pentanol. I'm going to number them 1, 2, 3, 4, and 5. So the OH group here is attached to carbon number 1. So it's 1-pentanol. Then I see my substituent groups here on carbon 3 and carbon 2. They're both methyl groups. So we're going to say that's 2,3 dimethyl 1-pentanol. Ethers have that oxygen atom attached to with single bonds to 2 alkyl chains or 2 aromatic groups. The name for an ether is taking just the names of the alkyl groups and put them in alphabetical order. So here we have a methyl group attached on one side of the oxygen, and here we have 3 carbons. That makes it a propyl group. So the name of this would be methylpropyl ether. So looking at a couple of ones here, I see I have, so here's my oxygen, and I have 2 carbons on one side, so that's an ethyl group. And here I have 1, 2, 3, that makes that a propyl group. So the name of this would be ethyl propyl ether. Looking at the second example, I have, here's my oxygen in the center. Starting to count, I have 1, 2, 3, 4. That is a butyl group. And then I have 1, 2, 3. That makes that a propyl group. So then this one would be propyl butyl first, alphabetical, ether. Methanol, also known as methyl alcohol, is the simplest alcohol. It's found in many solvents. It's found in paint removers. So it's a very common substance. If ingested, methanol is oxidized and turned into formaldehyde, which is used to preserve dead organisms for observation and dissection, and that can cause headaches, blindness, and death. Methanol can be used to make plastics, medicines, and fuels, and is used in car racing as a fuel because it's less flammable but has a higher octane rating than gasoline. So we have lots of uses for methanol. Ethanol, also known as ethyl alcohol, has been known since prehistoric times as an intoxicating drink. Its product is formed from the fermentation of grains, sugars, and starches. So we have here glucose is fermented, and the byproducts are ethanol and carbon dioxide gas. Biofuels has led an increase in production of ethanol. Mixture of ethanol and gasoline is sometimes known as gasohol. But if you look at the pump, whenever you're pumping your gasoline, it usually says it's about 10% ethanol. Ethanol can be used in hand sanitizer. And the amount of ethanol can be really high in ethanol based sanitizer, as much as 85%. So this can make hand sanitizers actually a fire hazard in the home. So you got to be careful with a hand sanitizer because they're very flammable. Most alcohols are very flammable. And also, ethanol can be made commercially by reacting ethene, double bonded, with water at high temperature, high pressure, and that makes ethanol. That is a commercial production of ethanol. Some important other important alcohols is called ethane diol or ethylene glycol. We have not just one OH group, but we have two OH groups. So 1,2 ethane diol, di meaning two, so diol. It's an antifreeze. That's the most common antifreeze used in heating and cooling systems in your car. It can be used as a solvent for paints and plastics. It's extremely toxic if ingested, but has a very sweet taste as well. It's very toxic to pets and children as well. We can have a tri-alcohol, a 1,2,3 propane triol. So here we have our propane group, and we have 1,2,3 OH groups. So it's called a trihydroxy alcohol. And this is commonly known as glycerol or glycerin. You may have heard of glycerin before. It's a viscous liquid, means very thick, obtained from oil and fat in the production of soap. Having 3 OH groups makes it very attracted to water, so it's strongly water soluble, and it's used as a skin softener and used in lotions, cosmetics, shaving cream, soap, and all those kinds of things. Phenols are found in lots of essential oils, which gives us the odor and flavor of the plant. So nutmeg flavor is a phenol. So here's our aromatic group, and here's our OH, our phenol group, and then there's actually an ether and another side chain there, but the main thing is we have the OH group. Here we have thyme, has a di phenol there. Cloves having a phenol group, and vanilla also having a phenol group. Ethers have been widely associated with anesthesia for surgery. Diethyl ether was the most widely used anesthetic for more than 100 years. It's very easy to administer, but ethers are very volatile, meaning they evaporate very quickly, and they're highly flammable. So a small spark in the operating room could cause an explosion. So you had to be really, really careful with diethyl ether. In the 1950s, some new anesthetics came onto the market that are not as flammable. These are known as Forane, Ethrane, and Suprane, and Sevoflurane. So there are several different ones there. You don't necessarily need to know all of them. But they've been developed, they're not as flammable. So they still have their ether group. Here's our oxygen in the middle with carbons on either side. But many of the hydrogens have been substituted with halogen atoms, fluorines and chlorines, and that reduces the volatility and flammability of the ethers. So ethers have a very important use in the medical field.